Hey, everybody. How is everybody doing today? Dave Cooper, and it is BS Friday, Building Science Friday, and we got Mark the Bare Naked Willie down below giving us thumbs up, and I love it. I love it. This is going to be a SIGA North America day. We're going to talk about the top 10 things that you need to be aware of and understand about air barriers. And we have two experts with us. We have the CEO of SIGA North America, Etienne, with us. And we also have Sean out of Canada, who not only is with SIGA North America, has a very successful podcast, but also another brilliant guy. So listen, if you're just joining us right now, we are on 3 locations, LinkedIn, YouTube, and Facebook. Please hit that like and share button right now. And as always, make sure you subscribe to our YouTube channel. All right, everybody, let me get my banners off. I see I'm still running stuff here. Etienne, I wore a suit jacket for you today, my friend.
I really appreciate that, Dave. So yeah, next time I will do too.
I love it. I love it. Hey, Mark, why don't you kick us off today? I mean, this is so close and near and dear to your heart that I think this is a good topic for you to kind of hit the show running.
I'm going to kick us off, Dave, by saying you look great, brother. We got to watch you leaving a meeting and walk down the road with the Alex Rodriguez glasses on. You look great. I wanna start by thanking everyone for tuning in, and it's thrilling because Dave's in Connecticut. I'm in the Midwest. Etienne is in the greater Midwest, and Sean is joining us all the way from BC. And it's really great to have the dexterity of SIGA involved in this, because you guys are such good partners in how you work together and managing this huge territory of North America. And it's thrilling to have you guys on the show. So I just want to kick it off by saying this is awesome. And I'm so happy to have my good friend Etienne and Sean on with us today. Welcome, fellows. Welcome.
Yeah.
Thank you for having me, and awesome, of course.
So why don't we kick it off, Etienne? Let's give everybody a reintroduction. We've had you on the show before, but why don't you take a minute and give everybody my typical, you have 5 minutes to tell us everything from your childbirth until this very moment in life, but don't go over 5 minutes because we will buzz you.
All right, let's go really quick. So hi, everyone. My name is Etienne. I'm responsible for SIGA North America. We are mainly focused in Canada and the US. We strive for a world of zero energy loss buildings. That's our vision, together with over 15 employees here. This is the vision we go for. I'm from Switzerland originally, been with the company for 7 years now in the role as CEO, and just super excited to be here today. One last thing, I'm a certified passive house consultant. I have a big passion for passive houses or high energy efficient buildings. And therefore, I'm super excited that we can talk about air barriers, air tightness, since this is one way to save over 30% of energy in each building.
Yeah, for sure. Love it, love it, love it. All right, Sean, listen, I want you to give your background, but I also want you to give a plug to your podcast, man, because what you're doing is awesome. And I think people should know what you're doing up there, all right?
Perfect. Yeah, thanks for having me on the show, Dave. Appreciate it. My name is Sean McStay. I'm the National Sales Manager for Canada. I've been involved in sales and construction for over 15 years now. I'm also, like Etienne, a certified passive house consultant. I've been with SIGA for just over 5 years. I was the first employee up here in Canada, and we've since grown the team out. We've got 9 people in Canada now. And so we are doing our best to support airtightness, passive house, net zero, fits high performance. We want to be involved with that. And I appreciate the chance for talking about my podcast. It's a passion project for me. It's called the Better Construction Podcast. I've been fortunate to have some amazing guests on: Steve Basic, Mac Reisinger, Jake Bruton, Peter Yost, Christine Williamson, you name it, they've been on there. So I've been very fortunate to get them on there and to chat about the importance of building better, because at the end of the day, that's what we're all here to do.
Absolutely. Absolutely. And it's so great to have other people in the industry spreading the word. So, Mark, I mean, we have all these wonderful guests tuning in. I see the comments lighting up already. I think this is going to be a lot of fun. The show's great. We got some good accents on. I love the accent that they bring. Why don't you tell us why this is so important, Mark?
It's plain and simple. Most of us, and I say most of us, meaning all of us, have experience in buildings. And the experience can either be wonderful or it could be rather uncomfortable. So these buildings range from new and old, from existing, as we call them, to just cropping up or being renovated. And so when you take on a building, you have to evaluate it, and you have to see what the building's telling you, and you have to plan for the experience of the people of the building. So planning involves a good team. It involves the right materials and the right installation and process of those materials. It could be rather difficult for someone to take that on. And so you need a team of professionals to do that, and you need a supplier. In this case, the supplier happens to be a manufacturer. So they're very in tune with what has happened, what is happening, and what is coming up. So it's transferring these years, decades of knowledge from Europe and bringing it to North America. And the experiences that these guys have and the level of training is at the absolute best in the industry. And the trainings they offer is also unfounded. And so we have to embrace that. We have to share it. And that's what we're doing. And so this is awesome. And you guys narrowed it down to 10 points. And that's extremely difficult to do. And I think that's what people need to hear, that it can be done. And these are the 10 steps to keep in mind.
Yeah. You know, and just to, Mark, to add to this, you guys also have your own research lab. So not only do you manufacture your product, you stand behind your product, but you're doing the research because you need to be putting something out there that is superior quality, superior, because you own it soup to nuts. And that's, I think, super important for somebody to understand.
Yep. It goes from their development all the way down to the training, the job sites these guys go on, the interaction between architect and consumer and contractor and many tradesmen along the way. We have these things called penetrations in buildings that could be really big, and they need to be non-existent.
Yeah.
So
I love it. Well, so why don't we just say, hey, listen, if you're tuning in, please hit like and share right now, because we're going to right now get into the top 10 air barrier questions, thoughts, the science behind it. And we're going to try and make this a very, very interactive conversation. So you in the audience, please tune in and ask us questions. So here we go. Etienne, you're going to be up first, my friend. The first question today is going to be, is there a difference between an air barrier and a vapor barrier? Go for it.
Yes, absolutely, there is. What's very important with the terminology, and I think just to kick off today's discussion, we really need to define a few terms. There are different barriers in our wall assembly, and they're also located at different locations. And often, for example, a vapor barrier can and will serve as an air barrier, but you also have other barriers, for example, like a weather resistive barrier that can also be an air barrier. So it gets a little bit confusing. Actually, I brought you guys a picture here that will work quite well to show where these barriers are typically located in a heating dominated, that means a cold climate. Let me see if I can pull that up here.
Yeah, let me get it for you.
Perfect, thank you so much. All right, so here you can see, so typical wall, blue is our weather resistive barrier. Obviously, that one is always on the exterior of the building. Why? The functionality is to protect the building from moisture, from the weather influences, wind, during construction and afterwards. That's your kind of backup plan once cladding is on, okay? That one is on the outside, clear question. Inside, vapor barrier can be a vapor retarder. Once again, that depends a little on the climate. And now air barrier. So air barrier can be in multiple locations. Each of this product can also be an air barrier. So just want to be clear, if we talk air barrier, it can be all of them, it can be none of them, and we will definitely dive into today quite deep on these different versions. I hope I could answer this question.
Yeah. Go ahead, Mark.
Yeah, so the WRB, Etienne, so when people think about water comes in many forms at a building, right? Bulk water, then we have vapor, and what's the other one? Moisture itself from condensation?
Yeah, I mean, yeah, I would probably consider that vapor too. You know, in theory, ice. Then you have all the three forms. You know, the gas, liquid, and kind of frozen. Yeah, but typically buildings deal with bulk water. That's the main functionality of a weather resistive barrier, is to address bulk water first and foremost. And you don't necessarily need to tape that membrane. You can shingle it, and it will do a pretty decent job in most of the locations to keep the water away, right? Once you start to tape it, you can turn this thing into an air barrier with the right products and right execution. So yeah, it can become an air barrier as well.
Right. Depending on the WRB you use, you can modify it to bring it into the air spectrum. Correct.
Correct.
Can you give us the definitions again, real quick? WRB.
Weather resistant barrier, and typically, Dave, the WRB again, what ATM wanted everyone to know is that bulk water is being kept away from the, typically it's found behind the cladding, right? That's what your assembly would call for. If you put the WRB in a different area, please send us a picture.
Yeah. Well, we love the biggest mistakes on this show, right? What's the stupidest thing you've ever seen? All right. Love it. Question number 2. Mark, go for it, buddy.
So Sean, this is going to you. These are words that not everyone knows. So what are convection and diffusion? And please tell us what they have to do with air barriers.
Definitely. So, I mean, this is a really important concept for people to understand because there's absolutely massive difference between these two forms of moisture transfer and how much of an impact they're going to have on your building assembly. So obviously our main goal, like Etienne was mentioning, is we want to prevent moisture from getting into our wall assembly. We want to do that to make it last longer, make it healthier, and ideally make it more energy efficient. A lot of people will look at diffusion, and that typically is expressed with perm rating. And so we talk about perm rating of different materials, of plywood, of your WRB, and people will be very concerned about the perm rating and the ability for the wall to dry based on that perm rating. What they sometimes forget, though, is that convection can transfer a tremendous amount more moisture than diffusion ever will. So diffusion, over the course of a typical heating and cooling system, if you have a typical vapor open WRB, diffusion might be able to transfer 24 ounces of water roughly. If you have some holes in that, though, and you have convection, which is the airborne driven moisture, you will actually transfer in that same period of time in that same assembly over 220 gallons of water. So this isn't a small difference, and that's why airtightness is absolutely so critical, because diffusion, it's important, we have to calculate it, but if you get convection wrong, you've got a waterfall in your wall instead of a cup.
So it's mind numbing, right, Sean? And when you put it into these empirical terms, when we have gallons, 220 gallons over that same spot pouring in. So convection is basically acting like a team of shop vacs on a hole and just bringing that water into areas that water does not belong.
Absolutely, absolutely. And that's why airtightness is so critical. Diffusion, like I said, it's important. We calculate it. We help our customers out with that for sure. But first, has to be airtight, handle the convection.
Yeah, for sure. And what I don't think a lot of people really understand is, and this is why we have the show, the science behind all of this, because just today, just in the area I'm at, looking at, because now I'm a building science geek, I guess, I'm looking at how people are putting house wrap on homes and realizing, how wrong it is. And I'm finding myself being critical of other people's work, and I've not ever been that way. But, now that I understand the science behind it, man, it makes a whole lot of sense. And if people can get this right, it'll save them, whether you're a builder or developer, doesn't matter if you're building green or not. You get this piece of it right, it'll save you a whole lot of headaches in the future.
Yeah, it's not difficult work, Dave. It's just knowing the right people to talk to and having them show you the steps to put it on. As you learned in your training with SIGA, the simple roller, right? That seconds of work is a lifetime of smiles. That's all it takes.
Right.
More than a lifetime, because truly it's longer than our life. So thank you, Sean, about making that so clear and impressionable, because it needs to be impressionable about the water.
Well, and for builders, the big thing to remember, the number one reason of wall failures and the number one reason for callbacks is moisture problems. And so if you can have a way to get rid of those moisture problems, you're going to save yourself a lot of time and money and headaches, in addition to, of course, building a high performance assembly that's going to serve your customer well.
Right.
Water always wins, right? So how can you keep it in your glass and by your trees, not in your walls?
Yeah, not supposed to be in the walls. All right, so listen, everybody. I know there's a lot of you tuning in, and there's a lot of, I see the comments bar lighting up. We're going to get to you after this next question that we're going to do right now. And this is question number 3, and this is for Etienne. What critical functions does an air barrier perform?
Oh, that's a fantastic question. So I think the one that we just talked about, it will stop any convection flows. So that is super important, because if we don't have hot, humid air in our wall where it could potentially condensate, we can eliminate the biggest risk that we have, which is mold. So mold needs moisture. If we stop that moisture from getting there, that's one of the biggest critical functions. It protects your wall. Another function is as well comfort. If you don't have any airflows through your walls, that means there are no drafts, right? There are other positive points, of course. The energy efficiency of your building, that's a big one, because if you can control your condition there and kind of encapsulate it so it's not just leaving through your wall, you can heat up your interior volume once and it stays there, and you don't have to keep heating. Your heater doesn't need to run 24/7 to keep you warm, or your cooling needs to run 24/7 to keep you cold. So big energy efficiency point there. Noise is also a big factor with air tightness. We see that a lot in urban areas where we have a lot of traffic outside, for example. If you seal up your window joints and everything, it helps a lot with noise transfer, because noise is transferred through the air, right? It can help with smoke development if you happen to have a fire. So there are a lot of really good elements to why you should build airtight, and kind of benefits you get out of building airtight.
Yeah.
The energy efficiency part that you said, and the comfort part, and the quiet part is a benefit, right? Because you're controlling the heat staying out, or the heat staying in, or the cold staying out, or the cold staying in. And for all the people with snarky comments out there, Etienne is not saying that we do not ventilate properly. We do ventilate properly. This is not a show on ventilation, but none of us in this conversation are telling you not to ventilate. In fact, we're telling you could ventilate continuously without using your heat and cooling, because you do not need the heat and cooling at the same level as you're used to. So just wanted everyone to be clear on that. We're not overstepping it. We're outlining the benefits of air tightness.
Yeah, 100%. I want everybody also to understand, with these air barriers, they breathe. And this is what's important. They can keep water out and let air through in two different directions. Am I accurate in saying that, Sean and Etienne?
They let moisture through, not air. So
moisture. Thank you. All right. So to clarify, that's what people have to understand. The moisture can penetrate and work its way out of the walls, but not let it in the other direction. And I think as we're going through this, for those of you who are here to learn this and are not already experts in this space, that's a really important thing to understand in what we're talking about when we talk about this moisture transfer.
These are smart membranes. The air is canceled and the moisture is allowing to go the direction it's supposed to go.
That's right. That's right. All right. You guys want to jump in to see who's with us today?
Please,
yeah,
Dave.
Yeah. Who is there?
Always fun. Always fun. Hey, guess what? Mark Willie's with us. What's up? Yeah, buddy. Hey, Mark, did you know you were here today? You are. All right. Hey, George Ryman, time for my weekly dose of BS. Good morning from still hot Phoenix, Arizona. I know it's always hot in Arizona. George, come out and visit us, man. We're having these beautiful 70-degree evenings right now, and it's absolutely lovely. All right, here's one of your biggest friends and foes. We got Adam White. Hey, all, let's do this. Good to see you, Adam. Thank you for joining us. And we have Jennifer did join us from our meeting, so she made it back in the background. So welcome, she says. Our good friend Andrew Seeley. Happy Friday. Happy folks. Bring on the BS. I love the PH. What does PH stand for?
I think it stands for particularly happy in a passive house.
There you go. That's the new word. And we got good old Joel Hutchins from Splash Modular. What's happening, Joel, my friend? I hope you recovered from quarantine in Australia. Rick, we got good old Rick from Hot Atlanta. What's happening, Rick Hawkins? Ferris Bueller with no hair. I love it. I love it. And we got Jordy Butchinger from ModuCore. Listen, if you're in the modular manufacturing space and you don't know what Jordy and their team are up to with their technology and their software, I highly suggest you reach out to them right now. He looks like a mad scientist in that picture, doesn't he? Love it. Love it. All right. We got Adam White, top of the league in air tightness. Thank you, Adam. Man, we got a lot of people just commenting in good faith. Hey, Joe Butler, man, I'm ready for my weekly training session. So here's another guy, been in this industry a long time, especially offsite. You know, he knows just about everybody in the offsite world. He's been doing it that long. Joe Butler, I'm glad you're joining us today. Rick Hawkins, great link for retrofit US usage of SIGA. Oh, there must be a link coming up. Great link. Let's see. Here it is. Green Building Advisor energy retrofit for an old timber framer. All right,
one, Rick. Good one.
Appreciate it, Rick. Love it, love it, love it. All right, still going through here, everyone. Buzz, we got Buzz Holitzer. Hey, what's happening? Preach it, bearded one.
That's my brother, the Buzzard. How you doing?
What is happening? We got Tom Reddy from Synergy Steel. What's happening, Tom? I hope it's going well for you out there. Man, we got a lot of people tuning in. We got Ken Kiefer. All right, now this guy's from SIGA, and let me tell you about him, right? And I'm going to give you all the bad stuff first. He knows way too much about air barriers. I had to go sit through, when I say, that's the wrong way to say it. I chose to go sit through his air barrier house wrap training, and I have to tell you, he made it so much fun, and the technology and the way he talked about it, and this isn't a sales pitch. Ken, you got it going on, man. You really know your stuff, and I appreciated it, and thanks for geeking me out on air barriers. So love it, love it. We got Miles Biggs Ideas. Happy Friday, folks. Man, we got them all. I got 3 more, and then we're going to move back into our questions. Jessica Coomer, get it right, build it tight. Hey, Jessica, thank you for tuning in today. And we have another one. Jessica Coomer stole the words out of my mouth, Ken Kiefer. Hey, I love it. I'm glad that we got a lot of support coming in. So listen to this, guys. That's a whole lot of names to get through just in the beginning, and we're not even halfway through the show yet. So we better get our butts in gears, and I better stop running my mouth.
Let's go to the next banner and get Sean started, because Sean's the person we want to hear from here. Please tell us, Sean, what materials can be used as an air barrier? Take it away, brother.
Perfect. So this is a great question I get often, and I kind of demonstrate it this way. This is a piece of paper, sticky note. This is an air barrier, because if you blow through it, nothing's coming through. However, this is not a very durable air barrier. So there's got to be a difference when you're doing this between what is an enduring air barrier and what is airtight. So when you're building these buildings, as we all know, we're going to be doing blower door tests on them. The blower door tests are done at the time of construction. And there are lots of products out there that might get you airtight just for that particular period, but aren't designed for long-term airtightness. And this isn't a slight against that product. It was probably designed for waterproofing or something else, and people are making use of it for airtightness. Absolutely need to look at the products that are going into any part of your airtight envelope and decide whether it be, you know, part of your stucco, the wood sheathing, your WRB, your vapor retarder, paint even sometimes people use. Is it physically capable of being airtight? That's your first question. And then the second question, for how long was this designed to be airtight? And that's when we start getting into some of the difficult questions with things like spray foam or some products like that that might be airtight at first, but not designed for long-term airtightness. So those are the 2 really crucial questions you have to look at.
Yeah. Go ahead, Mark.
That's important, Sean, because you're saying, yeah, we achieved it. Right, we passed our blower door, and now we can move on with our drywall, or whatever step they are in their process. But what you're relaying to people is these years of experience and these years of testing show this is a fix for a set period of time. It's not a solution for the duration, and I think it's great that you point that out and make it clear. Yeah, you get a half thumbs up, but then you're getting a period of thumbs down after that, and that's going to add up. So,
absolutely,
great point on all those things, Sean.
Yeah.
And nothing's worse than doing a mid-construction blower door test. Partway through your build, you pass it, your numbers are good, you think you're good, and then something gives way in the next 6 months, 9 months, whatever it is for the rest of your build. Now you're drywalled, you're finished, you're doing your final blower door test. Maybe your local code requirement is you have to be airtight, and you fail. That gets really expensive really quick.
Yeah. And let me add to
And
this.
even still, then it's a Band-Aid after that. It's not part of the system
Right.
of success.
Yeah. Well, let me add to this. This is something Kenneth taught me in the SIGA training, right? You take a window, and in today's practices, everybody says, all right, well, I'm going to spray foam seal around the gap in that window, right? Especially site builders where the lumber's made a little moist still, right? Well, what happens over time, that foam hardens, within a day typically. And everybody knows if you had to peel some of that foam off, it holds its position. Well, the wood around the windows is expanding and contracting all the time. That's where the moisture is. That's where the heat transactions are happening. So what happens when that wood expands and contracts? I think I heard the house expands and contracts like 1.5 inches a year. It's huge. That's why your doors stick some seasons in old houses and some seasons do not. Well, guess what? That air barrier, that foam is not expanding and contracting with the home. And correct me if I'm wrong, but that's what's causing some of the air leakage after you had that first blower door desk that you did so well on when you first built the house.
Absolutely. Yeah. You got to look at what the product's designed for. And I mean, that's one of the nice things about SIGA products. And to be fair, a lot of other high performance products that are designed for air tightness. It's not just SIGA. There are others. You only use SIGA, of course. But the ones that are designed and tested for that, I mean, we test our products to last 50 plus years. And that doesn't mean after 50 years they fall apart. That means after 50 years, they're just as flexible and sticky as they were the day you put them on.
Right. Yeah. And that's super important. And I think that's awesome. All right, we ready to go to the next question, gentlemen?
Nice job, Sean.
Yeah, very good. All right, Etienne, this one's for you, number 5, and I know we have some photos, so you tell me when you're ready for them. Where should the air barrier be located in the wall assembly?
Well, it depends. So it depends on what you're building and what your goals are. I think that sometimes you have certain conditions that are given. Let's say I have some modular manufacturers or panelized manufacturers, and they happen to utilize an interior OSB sheet for shear strength. Also, it helps them with transporting their elements once they are insulated with blowing insulation. And so there we can actually make use of this interior OSB. So an air barrier can totally be on the interior of your wall. As Sean said before, there are different products that will be airtight. One location where an air barrier is quite well protected is mid-wall. So you can use your exterior sheeting and tape that sheeting. That's a very common, I call this kind of an entry-level strategy to air tightness. We see that across the country when building codes get tighter and air tightness becomes a topic, often a go-to method for a lot of builders to tape their sheeting. But you can also, as we discussed earlier, use a weather-resistive barrier. Now, I have 3 pictures to give you kind of a visual for that. Let's start maybe with the interior or exterior. So this is modular manufacturer out of Washington. It's blockable. They're doing a fantastic job. Here you can see they are using a self-adhered weather-resistive barrier that will also serve as their air barrier. Okay, so that is one approach. I would say, in my experience, the most common, most famous approach in North America. That's often how air barriers are done in typical builds, right? Good. So what's important is attention to detail. Every penetration needs to be taped, right? And you really have to think what comes next. Because if you, let's say you want to go with cedar shingles and you're gonna pop hundreds of holes into this, these are things you really have to think about. If this is your air barrier, is this going to work? What comes next? But that would be an exterior air barrier.
Yeah. Sorry to have your face covered there, Mark. I was looking at the picture. Good.
Everyone's looking at the picture, Dave.
I love it. All right. So you want to show some more of these photos?
Yeah, absolutely. Yeah, let's look at another one. Okay, so that would be an interior air barrier. It's the OSB, the sheeting. That was kind of the example of a panel where we had the blow-in cellulose. So that was a good way to transport. You can also see something interesting. Do you see those furring strips? That's an important step. If you want to use this layer, the furring strips are here. We call this a service cavity. So you can run your cables in there, and you really limit the number of penetrations that you will have into that air barrier. Also important, an interior air barrier, it there are other options. There are smart membranes. There are other products that you can use. That was just an example for your audience here. Yeah.
I love it.
And then last but not least, I brought you a mid-wall picture. This would be kind of a mid-wall air barrier, tape sheeting, plywood, OSB. There are a lot of sheeting materials that you can tape. That would be kind of a common first step, often what we see in the field.
So you're taping these areas up. That's a specialized tape that you guys have, correct?
Correct. Yes, we have a tape that can be used on the outside. It will be UV resistant for 12 months. Sometimes we know jobs get a little delayed. The tape doesn't care, so that is a good way to also have kind of a little bit of backup.
So
plan.
very, very important thing. How long can the product be uncovered?
Here, in this case, it would be 12 months with this particular tape. I would say, if we not just talk SIGA, it's between 3 months to 12 months. That's kind of the range for building products where they can be exposed. I would say for weather-resistive barrier, 3 to 6 months. And the UV exposure, maybe a topic for another day, very, very serious topic. Products can get sunburned, same as humans. It will accelerate the long-term deterioration of those products. So very important to keep that in mind. You know, if a project is open for a few years, the wrap is totally faded, don't cover that up. Sorry, you can't. You know.
It's a good point. So Dave, you in your training, you remember the flexibility of these tapes, and as well the adhesive, or it's not really an adhesive, but how well it sticks, right? So on those pictures, you see the applications, very good installations, but you also have a duration of time where these plywoods and OSB cannot be exposed to the weather. I can't speak for the R&D department of SIGA, but I would say from the wood industry, I'd be more concerned with the plywood and the OSB than I would of the tapes.
Yeah, for sure. And you're not kidding. You know, if you take that stuff and you just lay the roll down on a table with no, unsticky stuff like you have on the back of stickers, I mean, it's a workout. You know, it's like what is it? Thor trying to pull the sword out of the rock. So it's sticky stuff. But yeah, absolutely, I agree. And it was very elastic, so it really did move. But yeah, no, it was a lot of fun. All right. Go ahead, Mark. I see you got something to say.
No, I want to jump in with Sean because I know his next question has a bunch. Thank you, Etienne.
Yeah. All right, here it is.
So we run into this all the time. Everyone has their Stephen Basic or their Peter Yost or their Joe Seabrook story, Sean. So can you go as detailed as you like and let us know, is it bad to have multiple air barriers?
It's a great question. It's one we get asked pretty often, and it's an important one to look at. And it goes back to the question that I was answering earlier about convection versus diffusion. So if we have multiple air barriers and we're definitely airtight, we've eliminated the convection. So now we need to look at diffusion. Very important to start out when you have multiple air barriers. I'm fine with that is the quick answer. It's like a belt and suspenders approach, especially if you're looking for really low results, like a passive house level results. Always good to have a little bit of a backup there, but you need to make sure that everyone on site understands what the primary air barrier is and knows that that one is absolutely crucial. No cuts, no drill holes, no any of that stuff. And then the secondary air barrier can be as airtight as you want as well. When you get to multiple air barriers, though, and this is where probably people watching and having comments are going to be concerned, that's when diffusion and permeability becomes super important. Because if we have a wall assembly that is airtight on the outside, airtight on the inside, and both of those are vapor closed products, then you're going to have a problem because any moisture that's in that wall assembly during construction or might happen to get in there afterwards is absolutely trapped in between those two. So you need to make sure that you do a wall calculation to ensure that your wall is going to dry. That's a service that SIGA offers for free. Other companies do that as well. There's a few different programs, Woofy, Delphin, depending on the type of wall that you have. But they take that wall assembly and they look at all the components, the insulation, the wood, even down to the exterior color which direction it's facing, is it south, is it west, etc., and exactly where your project's located. And they figure out through the course of the year, is that wall going to be able to dry based on the products that are in there? And so at SIGA, we do that as part of our calculations for projects. It's really important to nail that. And if you're going to have 2 air barriers, make sure your wall can still dry.
So this is excellent. So think about this. You're building a building, whether it's single family home or multifamily construction, and you're telling me I can send you what I'm building and you guys will run the calculation on exactly what I need to do. I don't, as a builder or developer, have to think about that. And I can mitigate my risk by leveraging something you guys do day in and day out to help me understand which way the water should flow on my walls.
Exactly. Yeah, we have 2 dedicated application engineers in North America on staff, and they do that in addition to a number of other things, obviously. But they have the computer programs, the understanding to be able to do that. And, on larger projects, typically there's an envelope engineer or someone else involved that will have already done that, and that's okay. But where we really like to be of service to our customers with that is on smaller projects where maybe that hasn't been done. Or maybe the builder says, hey, I want to use a better material on here. This is important to me. I'm going to change what was specified and I want to use a high performance material. And they need some backup to be like, yeah, this wall is going to work and it's going to work better. That's where we're happy to step in and do that.
I love it. I think that's a phenomenal service. And I also think people really have to understand when you're talking about interior and exterior air barriers, you really have to know what you're using, or if you trap that moisture in your walls, well, we all know what that leads to, and that's not good. And I think that's where you can make a simple mistake where you're trying to do something right. So you better understand the products and what their actual job is, because they're not all made the same way scientifically. So Etienne, what I've just learned is you're not the guy that's doing all the air barrier science tests for all these buildings in the United States and Canada?
No. We have a big team here, so it's not just me.
Yeah. Well, I love it. All right, listen, let's go to, we got some, I'm lit up over here, comments. Let me just see who's there, and we will come back to some more questions. All right. Kenneth Kiefer. Shucks, you're too kind. Hey, man, never too kind, dude. When people know their stuff, we want everybody to know they know their stuff. So if you're out there listening and you're hearing what we're saying, this is a very skilled team doing some super big projects across this country, and I think it's very valuable to know that. And I want everybody else also to know, I mean, it sounds like we're tooting a lot of horns here. This is not paid for or anything. This is by invite because they're doing it right, and I think that's what everybody out there has to understand. I personally like all these guys and what they're doing, and the girls on their team that are tuning in. And I think it's really important that people understand that it's an important topic, and these are the pros leading the way.
Yep, so, this building science community shares a lot, and the fact that this information is available anytime on YouTube to go back to and refer to and say, hey, this guy Sean came on, or this guy Etienne came on, or Dave had this topic on. It's sharing the knowledge, and all of us are the first people to say, we're also sharing our contacts. We're also sharing what didn't work, and we're also sharing the opportunity to avoid a crisis, to create a healthy and comfortable space. That's what we're all here for, man.
Yeah, 100%. And you got to look at the life cycle of these projects. You can't just look at the one application. You have to understand the consequences from the very beginning through the very end, no different than offsite construction. If you look at the cost of just sticks and bricks compared to something else, we'll lose every time. But if you understand the full life cycle, you will see the value and the benefits. And that's what people have to understand. All right. I almost got on my soapbox, but I'm gonna.
It was close. It was close. I was ready.
I know. I got off my soapbox. All right. So, all right. Who else do we have here? So, Sean St. Amour. Morning, gents. Thank goodness it's Friday. It's not just Friday. It's BS Friday time. What's happening, Sean? I hope those private helicopter rides are treating you well, my friend. The rest of us need picked up every once in a while. You know what I mean? I don't know if you guys, did you tune into the episode where you had a helicopter landing in the background? Love it. All right, moving on. Adam White, I can't wait to get there with you guys. Watch this space. All right, Adam. Love it, love it, love it. Etienne, guess what?
What? Am I back
in the hot seat, my friend? You're back in the hot seat. I'm going to bring it. All right, here we go. how to answer, but the walls need to breathe.
So they don't. That's how you answer this. Walls need to dry and not breathe. Mark said it earlier, if your walls breathe, run out of the building. I think what's really important is to understand that we need an airtight envelope to control the air quality. And here is now where, if we talk breathing, we talk ventilation. The lung of a house is its ventilation system, right? This is where your filter is. This is how you get your air quality. But you can only control your interior air if you make sure you seal up your envelope. Otherwise, you will have air from the outside who could be polluted, right? If you think about that, once again, you're in an urban, in a city, a lot of traffic. The air outside is not great. The smog in some countries, quite a big problem. You don't want that air to come in. So you have to seal your wall so that the air that comes in runs through your filters, through your ventilation system. Okay, so your walls don't need to breathe. They need to be able to dry. Okay, that's a big difference. So close those walls and make sure you use materials that are permeable once again in colder climates. So if there is moisture in it, it can dry to the outside, not breathe, but dry.
Yeah. Anybody know anybody that has products like that? I'm just curious.
I'll ask around, Dave. I'll ask around. Maybe this guy or this guy or this guy or this guy.
Yeah. Well, I just thought it was a question that needed to be asked. You're in other words, Etienne, I'm saying you're too humble, man. I love it. So love it. All right, Mark, here we go.
So this goes back to you, Sean. Can you take us down a journey? Someone calls you up and they say, I don't know what to do here. How do I get my building airtight?
Yeah, absolutely. So, I mean, this is a question that I get. I'm always very hopeful that I'm going to get this question at the beginning of the building process and not partway through the building process, because it's the later you leave it, the more expensive it gets. But when you want to look at how you get your building airtight, there's 3 Ps. There's planning, there's product, and then there's performance. So the planning starts right at the very beginning, as early as possible, with the entire design team that's involved with this project. And you want to be able to basically look at a section drawing of that building, take a red pen, run all the way around that section drawing without lifting it up. And every time that drawing goes between 2 different materials, so between a wall and a window, between the top of a wall and rafters, the roof assembly, you need to understand that transition and how you're going to keep your airtight layer tight throughout that entire building. So that's number 1, planning. Once you're done with the planning and you're all ready to go, then you go to product. Obviously, you have to look at which products are designed for that, how they're designed, what substrates are they designed to stick on, what type of installation conditions are you going to have? Is it going to be hot, cold, damp, snowy? Make sure that all your products are going to work for that. So you pick your products out, and at the end, the 3rd P, performance. And that means for you as a builder, installing the product to a high level of performance. And the best way to do that is to get training, whichever manufacturer you pick. Make sure that you're getting training from them on site for your crew or your sub-trade, whoever's going to be installing the products. That's why SIGA makes such a big deal about training. We have over 500 employees around the world, and over 300 of them are trainers, because we want to be on the job site, teaching people how to install these products correctly, using as little of the product as possible, as funny as that sounds coming from a salesperson, so that they get the best result for their client and they don't have to have all those expensive callbacks that we talked about.
Yeah, for sure. I you know what? That's what's great about you guys, Mark has his red pens out. Are you gonna pull a who's the guy on the build show?
Steven Basic.
Yeah, Basic. Right. I couldn't get his name right away.
I'm gonna one up him, Sean. If you don't have the red pens out and you're not doing the trainings, you know what you're gonna have? You're gonna have the blues.
This is true.
Yeah. All right, love it. That was a great explanation for sure. All right, so here we go, Etienne. I know we have some photos with this one. We got a few minutes, so we're gonna get through 9 and 10 and keep this thing on track. All right, you ready?
Yeah, absolutely. Let's do it. Yeah, throw a few up and.
All All right. So the question, Etienne, look, I'm putting myself center. Top 5 air barriers mistakes. Top 5 air barrier mistakes, Etienne. You think you can help us understand what those are, my friend?
Yeah, absolutely. I mean, obviously there are hundreds of mistakes you can do. We brought a few pictures to illustrate some of those top mistakes, and feel free just to pick whatever you have there.
I'll start at the top.
Let's start with the top. So I think one big mistake is missed connections. All right. So this is a good example. This is a base joint. This is where the wall meets the foundation. And we see or have seen a lot that this connection just gets completely forgot. It doesn't get sealed up. Crucial connection. Why? Stack effect inside of the building. Heat rises, it pulls air in on the bottom, right? And so you basically, that's where the draft comes from. So misconnection is a very big reason for bad air tightness. Yeah. What else do we have here?
Yep.
Okay. Yeah. Here, Sean, why don't you take that one?
Yeah, so I mean, this is a diagram showing an interior air barrier, and what the number one mistake there is finding a way to connect in between floors. So if you have a multi-story building and you're using an interior air barrier, it can be quite challenging to connect between floors, and that's where it goes back to what I was saying, planning ahead. That involves pre-striping that connection or coming up with a certain product suite that are going to allow you to get through that connection there, that C-shaped connection, and keep it airtight. I always joke with my customers, you know, SIGA has 35 different types of tapes, whether you look at all the different splits and sizes and everything. They don't need to know that, but we do. And so we can definitely help out with getting through that connection point.
Yeah, interesting. So people normally don't think of these things being on the inside like this. Most builders are just doing just on the exterior of a house.
Yeah, and I mean, that's definitely a benefit to an exterior air barrier is you don't have to worry about between floors. However, with an exterior, then that top plate to wall to the roof assembly can become challenging. But as long as you plan ahead, you're fine. I mean, if you pre-strip that connection there, it's a relatively simple thing to do during the framing process. If you do it after the framing process, now your air sealing box ends in between every single little joist that's connecting to that wall plate, and that gets to be really expensive and time consuming. So the earlier we plan, the less money you're going to spend.
I love it.
So Sean, those are the times, I don't know, we have the photo of it where you see the picture of the wall is done and then you see the strip laying down and it's preparing for the joist coming in, right?
Yeah.
Oh, not that photo. Yeah, there you go.
Is that it?
Right. It's all preparation. It takes no time to put that on, right? But if you don't do that prior, then you're gonna have a little bit of scruples. That's part of the planning process and what you guys offer. That's a great photo.
Yeah, so, that makes it really simple there because I mean we've got an 18-inch wide MyVest roll that gets a detail roll. It's designed for that. Pre-strip it on. It's nice and easy to walk on. You tape the seams, and now you're ready. You can connect that exterior air barrier to your interior air barrier, nice and continuous. You don't have to worry about all the extra work.
I love it. That is such an important detail. And if you want to know what the name it is, just think MyVest. That's what I've heard. MyVest air barrier. Got it. All right. Love it. Love it. All right. What photo do you want next, guys?
This is whatever comes. I mean, you pick. Okay. So, yeah. So another mistake. So here it's kind of like, an exterior air barrier approach. What we see here is products that are not fully compatible. They start to discolorize and they will fall off. So it's just also material selection is one of the problems and starting to combine various materials. I think that's another big one, just as a quick point.
I mean, we're seeing 3 or 4 different materials used on one window.
Correct. Yeah. Another big one is project team awareness. So with air tightness, that's really important that everyone on the project understands this is a functional layer. If I damage it, if I do something to it, I have to say something. I can't just hide it or walk away. So that's a key element to get buildings airtight. Awareness, we said good planning, not missing any details, good overall condition, making sure that the conditions are right when you install. So just to give you a few.
Yeah, and with that picture, it's absolutely another one that's important is chemical compatibility. A lot of time that's not thought about until later. If you're trying to use two products from different manufacturers, because as much as I would love it, people aren't going to use every SIGA product all the time. They use some SIGA, they use some other products. I mean, we do free chemical compatibility testing for that reason, because the last thing you want is you put two products together and they start melting each other, or they just don't seal to each other, and you have a big mess on your hands. So definitely, when you're picking your products during the 3Ps phase, make sure they're compatible with each other.
Yeah, you would never randomly show up with different studs and different sheathing and different cladding and then say, how do we put a wall together? You would never, ever do that.
Right.
So why would you think about showing up with a different sweater, right? Or a different pair of gloves and a hat? You wouldn't. And that's what a team like this is here for, to give you the easy way to have a happy customer.
So if I hear you right, Mark, you're saying, let's not use carpenter's glue to put our plumbing PVC pipes together.
I could say let's not, right? Let's not use mayonnaise in our Cheerios in the morning, right? We know what makes a good breakfast.
That's it. All right, next picture. We got some wires coming through here. Let me pull this up on the screen for everybody.
This is classic, right? Everything was set up. The building was ready, and then we got to call Sparky. So Sparky shows up, and of course the carpenters are gone. Carpenters did their job. What's next, Sean? What happens now?
Yeah.
Well, I mean, at that point, you need a really good tape, which we know of a few, to be able to seal that. But the most important thing is you need to know that that's there. And so that goes back to Etienne's point of on-site communication. There's nothing wrong with the electrician needs to run a cable out, or a plumbing pipe needs to go, or whatever else happens. These things happen. It's the way building on site is, set up. But the communication is the key. Is 3 pieces of tape in probably 5 minutes. Maybe if Ken Kiefer did it, maybe 2 minutes. That wire is going to be sealed for the next 50 years. You forget to do that, that wire is going to be leaking hot, moist air out into your assembly and condensing and causing building damage within the next 5 years. So really important to have that communication for sure.
There's typically, and this is on a plan set, but things evolve and things change and get added, but there's typically at least a dozen exterior penetrations from plumbing to electric to mechanical to ventilation. And then on the inside, right, there's roughly 160 plus penetrations, depending on the size of your building, folks, right? So all this is they're telling you that we need to discuss that with all the teams. Someone needs to be responsible for relaying the information, and everyone needs to be responsible for relaying back, oh, this happened, oh, we did this, and then pass the torch and see who's going to take it on from there. It's brilliant. I'm glad we pointed that out, because it will continue to happen. Even in offsite construction, it'll continue to happen. We will always have penetrations, and we need to know how to deal with it.
100%. All right, so we have one last picture, Etienne. Looks like a foundation, and I have a feeling you're going to tell me I need to be tying my house wrap barrier, right, to the foundation. Is that my air barrier? Etienne, is that actually correct? Let me pull this picture up for you.
Yeah, let's have a look together. Okay, so this is an illustration of unfavorable site condition, or let me rephrase, a lack of substrate preparation. Sometimes if, for example, here you would tape up this connection once again, it is the base joint. Let's say we have a mid-wall air barrier, we would tape the plywood to this concrete, but you see all this debris, all that dirt, everything there. Yeah, the tape will stick great to it, but the debris will not stick great to the concrete. So that's a really bad thing. And we see that, so just one mistake is, bad condition. Either it's too cold for products, or it's not applied with the right thickness, or you have not a proper cleaning job before you install. That was more kind of one of the top things we see why things don't work the way they're designed to work.
Yeah, so it has to be clean.
Has to be clean. Yes.
Couldn't all projects be clean anyhow? Isn't that part of every trade's mission, is to make sure they leave it nicer than they arrived?
So if your family's coming over for dinner, right, and you're going to start cooking, your countertop and your sink and your stove isn't dirty, you clean it and then you start preparing the meal. If you're going to paint your garage door, right, and you walked in and out of there with your oil-filled hands, you're going to prep it before you're painting it. And it's all a matter of being a professional, because results matter. And the truth is, professionals want to do a good job and they want to leave their spaces better than they found it. That's a natural thing that you find in professionals. And so it's just looking for the industry mentor to say, can you train me? Can you give me a tip? Can you show me how to approach this? And the answer is yes, we can.
Love it. All right, listen, guys, we're at 1 hour. Here's the last question. It looks like we're going to make it through. It could be a new world record for Dave Cooper Live to get through 10 questions the whole show. You guys have been amazing. So let's do this here. Mark, Willie, go ahead. Go with it.
So I could go on for hours, because I wish Sean could take a whole hour on this question alone. BC has the best step code. Please, every municipality and professional listening, mimic BC or try to beat them. How about that? Be inspired, be challenged. So Sean, tell us, what does the building code demand?
So, like Mark said, it really depends on where you are. Here in BC, where I'm located, we've been pushing for green construction for quite some time, and the province has decided to implement step code over the next basically 10 years. And so by the end of that, everyone's going to be at step 5, almost passive house levels of performance, and they're going to be required to hit 1 air change at 50 pascals or less on their blower door test. There's a bunch of steps in between that to get people there, and we do have about a decade to do it. There are some municipalities that have decided to go faster. But when it comes to the people listening, if you're not in BC, make sure you are checking with your building code to see what is required for airtightness, because it's great to see there's more and more places, New York, there's places in Washington State, there's places over in Ontario and Canada on the eastern side that are starting to put out these progressive building codes that require airtightness. Now, why does that matter? Because if you don't hit it, you don't get your occupancy permit, and that gets really expensive. So again, make sure you're doing all the planning and preparation and using the right products, and you won't have to worry about not hitting building code, but check the building code first.
Love it. Love it.
Yeah,
so building code is a minimum. It's a minimum standard, and everyone's aware it's increasing. So you don't start the day saying, I'm going to put a half an apple in my lunch, and I know I have a 12-hour day, so I'm going to put the minimum, a half an apple in my lunch. Okay, are you kidding me? So there's a minimum. We're shooting for going beyond the minimum and reaching out. That point that you made clear, Sean, is a part of planning, and we cannot emphasize enough planning makes for efficient projects, and it also keeps people prosperous to do more work.
Exactly. And with building code, the big thing to remember, I mean, is the end user, the consumer of these buildings, have been trained through, HGTV and different places to hear, I'm building to code, and thinking that's a good thing. And so how I explain that to builders when they're trying to say, hey, how do I get my customer to care about this? Let's flip it to something that maybe they're used to, or maybe they've bought more often.